Hello everyone, in this video I will show you a type of questions related to system of linear equations. So the problem is that if they give you a system of linear equation, system of two linear equations, how can you tell whether the system has one solution, infinitely many solutions, or has no solutions? Okay, so let's recall that a system of linear equation, can be categorized into two big types. So either consistent or inconsistent. Okay, inconsistent. So inconsistent means it has no solution. And for consistent, we divide into two smaller categories. So consistent means the system has solutions. However, there's two scenarios. One is that the system has only one solution, exactly one solution. So exactly one solution, and we would call this type an independent. And the other one is that you have infinitely many solution, and in this case it's called dependent. Okay, so how are we going to do this? So for example, let's say I have the system of linear equation y equal to x plus 3 and y equal to x minus 1. Okay, so here's the deal. Now recall from previous lessons that we have the graphical representations of the system in terms of lines. So relationship between two lines, there are three, right? Either the two lines are parallel, either the two lines intersect with each other at only one point, and either or the two lines are exactly the same, so identical. So here in this case, solution parallel. So parallel will have no solution. Okay, so parallel no solution. So this one would be called inconsistent. For this one, the two lines intersect or cut each other at exactly one point. So only one solution, exactly one solution. So in this case, we would call independent. Okay, so this is independent, and for this case, the two lines are identical. So what it means is that every single point in this line is also lined on the second line. So in this case, we would call dependent. Okay, all right. So this is actually very helpful for us because we know that this y equal to mx plus b form is very easy to work with, especially when we have slope m and we have y-intercept. Okay, so just recall again, we have inconsistent parallel, so the two slope are equal, and B1 has to be different from B2. If the system is independent, then the two slopes have to be different from each other, and that's it. How about dependent? Dependent, we have same slope and same y-intercept. So I really want you to focus and remember this piece of information over here. Okay, so now let's apply to this. So let's say that we have let's number this as equation 1 and this as equation 2. So for equation 1, I have slope m1 equal to what? So the number in front of x, without written out, we know that this is 1. Okay, so the number 1 in front of x here. So m1 equal to 1 and b1 equal to 3. Okay, so for the second equation, we have m2 equal to 1 again, and b2 equal to -1. Alright, so which system is it? What type of system is it? So same slope, different in y-intercept, so we can conclude this is inconsistent. Okay, inconsistent. And look, without having to solve the equation, we can actually find out and tell immediately if the system has a solution or not. So this has no solution. Now for curiosity purpose, we going to solve this system anyway. So let's say that we're going to solve the system, alright? Now, the last time that we studied, we actually study how to graph this. So let's graph this. Okay, because we will later study how to solve this by substitution and elimination. So let's say that I'm going to graph the first equation, y equal to x plus 3. So 1, 2, 1, 2, 3, 1, 2, 3. Alright, so, and then this -1 here. So what happened is that I have y-intercept is 3, so this line here. And then the slope is 1, so rise 1, run 1. So I have this. Okay, and this is y equal to x plus 3. Now the second line is -1, so -1 is y-intercept here, and then rise 1, run 1 over here. So, and they should kind of like, parallel. You can actually eyeball this and say this is parallel. Okay, so they have no solution. No intersection means no solution. Alright, let's try another example. So let's say that I have y equal to 2x minus 1 and 3y equal to 6x minus 5. Okay, so we need to do a little bit of algebraic manipulation for this, because this one, equation 1 is already in the y equal to mx plus b form. However, this one is not yet. So let's say we will divide both sides of this equation by 3. So we would have 3 divided by 3 is 1, so y equal to 6 divided by 3 is 2, 2x minus 5 over 3. So this is my second equation. Again, so we would have m1 here equal to, let's say, 2, right? 2 is in front of x here. And y-intercept, which is b1, equal to -1. Remember the sign with the number -1. The same thing with slope for second equation. We have 2 and b equal to -5 over 3. Again, we have same slope and different y-intercept here. So same slope, different y-intercept. Conclude that the system is inconsistent. Inconsistent. Again, this means it has no solution. Alright. So let's find another example where let's see. Alright, how about this? Now another example, I have y minus x equal to 5, and 3y equal to 3x plus 15. Okay, so our strategy is to bring everything together to the y equal to mx plus b. Okay, so this is our goal. If you don't see our equation written in this form, you have to, transform it. You have to make it into this form. So in this case, both of my equation do not have this slope intercept form. So I'm going to do a little bit of transformation here. So what happened is that, okay, so in this case, the first equation is pretty simple because I just need to bring the minus x here to the right. Now, if you are not familiar with this, I would suggest that if you're not familiar with kind of like bringing things, terms back and forth between the left and right, and change the sign. So I would just suggest you that you just have to simply add plus x to both sides, okay, and that's the same, equivalent. So mathematical equivalent. So for this one, my first equation becomes y equal to 5 plus x. Okay, so a lot of people, I saw a lot of you write this, okay, and it's not wrong, but then again, try to have a habit of kind of like organize and rearrange it a little bit so that you can easily recognize, because I guarantee that people will actually misunderstand and confuse and choose the slope as number 5 and not x and not 1. Okay, so another step of rearrangement you need to do is to say this one would be y equal to x plus 5. And how about this? For this one, again, divide both sides by 3. So in this case, I have y equal to 3x divided by 3 is x, plus 15 divided by 3 is 5. So again, here in this case, I have the second equation is y equal to x plus 5. And this is actually interesting because what happens is that I have m1 equal to 1, b1 equal to 5. The same thing here, m2 equal to 1, b2 equal to 5. So what happens if I have same slope, y-intercept the same? Oh, I would have a dependent system. Okay, dependent system, or infinitely many solution. So if you graph the two lines, so you see the same thing, y equal to x plus 5 is exactly the same with y equal to x plus 5. So the two equations are the same and the graph will, the graphs are identical. Now, I'm going to show you something very fun. And that is, we're going to skip ahead a little bit and do this in a different way. So let's say that I rewrite this. Let's say I rewrite this. Y equal to x plus 5 and y equal to x plus 5 here. Okay, and I have equation 1, I have equation 2. Now I'm going to subtract equation 2 from equation 1. So 1 minus 2. Equation 1 minus equation 2. And what you would have is that you minus this. Okay, so you would have y minus y is 0. Okay, 0. And instead of writing 0, I would say 0y. The same thing here, I have 0x plus 0. Now actually, and then after that, I would have 0y equal to 0x. Now we know that any number multiplied by 0 equal to 0, so it's always true. and regardless of values of x or y.